this next video, we're going to be making things a little different. We've been doing a lot of math recently, very mathy problems. Now we're going to get into some word problems. We're going to get into some problems that hopefully kind of start to impact you in your real lives, and not just doing x plus 1 equals whatever. So here we're talking about interest. So you invest money into a bank, you take out a loan, you're going to learn about this thing called interest, which is you give someone money to borrow or you borrow money. You're not just going to be able to borrow it and then give it back. What you're going to have to do is we're going to make this agreement that I let you borrow this money, but then you also got to kick me 5% of whatever I'm letting you borrow in exchange for you getting to have my money. So we call that 5% that you'd be getting interest. So how can we calculate interest to figure out what financially makes sense, what doesn't make sense? So in this video, we've got this problem right here, and we're talking about compound interest. So there's simple interest, which is just you invest amount of money at the start, you invest it, let's say for 5 years. We're gonna give you a simple interest of 5%. Every year you're gonna get back 5% of that $5,000. So you get back $250 every single year of that 5 years. But now we're talking about what we call compound interest. So Drew, that's me, deposits $3,000 into a savings account where he earns interest at a rate of 5% compounded. How long will it take for Drew to have a total of $4,000? So just one note for this problem, or first off, I'll get into the formula we're going to use. So if you look it up on the internet, you're going to get a different compound formula. It's going to use different letters. There's different types of formulas. This is just the one I'm using, and I'm going to explain why in a second. So what I use is F equals I times 1 plus R to the power of t. So a couple things about this formula. You may see a formula that looks kind of like this online, but they're going to use different letters. I think it uses A equals P times 1 plus R to the power of t. I just changed the letters to make it make a little more sense for me, because what F really represents here is the final amount you're getting. So after that 5 years up, how much are you getting? So I call it F, so I can kind of remember that this is talking about the final amount. And then I, that's talking about the initial amount. So that just makes sense to me, because this right here is talking about what you're getting after all those years. This is talking about how much you're putting in at the start of those years. So if you want to use A and P, that's perfectly fine. These are just the letters that help me remember it. And then R, this is the rate, which is also going to be written as a percentage. And then finally T, we all know what T is. That's just talking about time. Okay, another thing about this formula. This only applies if our interest is being compounded every year. So what that means is at the end of every year, that's when the recalculation occurs and says, okay, you earned $500 in interest this year, but say you started off with $5,000 and then you earned $500 in interest. Compounded means rather than you only getting a percentage of that $5,000, now that your account has $5,500, we're going to take the percentage of that new amount. Whereas simple interest was we're just taking the percentage of the initial amount you invest. So places may compound monthly, they may compound weekly, daily. If that's the case, there's a different formula you use. You just have to change this formula up just a tad bit. But we're just going to be going over the case of your interest is being recalculated every year. If you guys want, for fun, to see a video with this different formula, let's say you want to learn about how we do this if it's being compounded daily, put it in the comments. I know our audience is expanding. We may have some viewers that aren't just my students, they might just like math. I see the demographics, I see you people in Sweden. We got a big Swedish audience. If my Swedish audience would like to see a video where we're talking about it being compounded daily, please just let me know. Alright, enough of the stalling. How do we do this? So when we have this big scenario here, I like to break it up piece by piece. And I like to identify each of these four variables. We got f, we got I, we got r, we got t. And so I just write f equals, I equals, r equals, and t equals. And I'm just going through this and I'm identifying what each of these numbers mean. So first, we have $3,000. What's $3,000 talking about? It says Drew deposits $3,000 in a savings account. That's talking about the initial value. He deposits $3,000. That's the initial amount he's depositing. So our I is going to be 3,000. Next, we have this 5% here. He says we get interest at a rate of 5% compounded. So that means our R is going to be 5%. But remember, we can't put 5% in this equation. We have to write it as a decimal. So we write it as 0.05. And then it says, how long will it take for Drew to have a total of $4,000? So how long tells me that we're solving for time. Time is what we don't know. And then it's asking, how long is it going to take for him to have a grand total, that final total, to be $4,000? So the final value we're looking for is $4,000. So now we just plug this into our equation here. So we have 4,000 equals 3,000 times 1 plus 0.05 to the power of t, since t is what we're still looking for. So now we just got to solve for t. And right when you see this, that we're solving for an exponent, your mind should be saying, oh shoot, we're going to be using those logs again. So how do we get this to a point though where logs are going to be useful? So we got to do just one thing pretty much. And we got to get rid of this 3,000. So how do we move this 3,000 over to the left side? And to do that, we just divide both sides by 3,000. And so these cancel out. 4,000 over 3,000, that just simplifies to 4 over 3 equals, and then 1 plus 0.05 is just 1.05, so equals 1.05 to the power of t. Let me make sure this is still in front of you. Perfect. So now, what do? We're stuck. We call on the logs. So now we're going to be taking the log of both sides. So we take log of 4 over 3, and we set it equal to the log of 1.05 to the power of t. Why do we do that? Because the log rules, it tells us that we're allowed to now move t to the front of our log. And I'm going to do this all up here now, so more room. We're left with log of 4 over 3 equals t times the log of 1.05. And so to get t by itself, we just got one more thing to do. We got to divide both sides by log of 1.05. We do that, these should cancel out, and you're just left with t equals We gotta get our calculator, do log of 4 over 3 divided by log of 1.05. Give me 1 second. As you guys know, I do not edit these videos, so just hang on tight. Give me a second to do this. You can fast forward if you want. So we have log of 4 divided by. And when I do that, I got 5 point. So it's going to take 5.9 years, if we're getting 5% interest, to go from $3,000 to $4,000. If you ever get a 5% interest rate, please take it. That's such a crazy rate. It's just kind of for the example, but you guys can see why interest can be cool. There might be a bank out there crazy enough to give you a 5% interest rate, and then you just do nothing. You just take 5.9 years and you get a free $1,000.